Okay, see Lindelof videos proving trigonometric identities, also often called verifying trigonometric identities. And what we're going to do today is left-hand proofs. So this is kind of how the rules work. The rules work that your professor will give you a side and say, in this case, prove that the left side is equal to the right side. And when he or she says that, what they're saying is that you can only change one side. So we're going to work on this side only and try to make it equal to this side. First thing I'm going to do is this. I'm going to rewrite this 1 over, cosecant theta is the same as 1 over sine theta, right? That's a reciprocal identity. So I'm just going to switch this out. So I replace this with this. This solidus or fraction bar, whatever you want to call it, is this one right here. And we know that secant theta is 1 over cosine theta, isn't it? 1 over cosine theta. Remember, we can't change this right side, so if you don't mind, I'm just going to kind of bring it down for lack of a better explanation. All right, so here we have it. If you can remember the rule of complex fractions, the rule of complex fractions says that if we have a fraction AB over CD, then we can rewrite that as AB times the reciprocal of this, so times DC. So that's what I'm doing here. I have 1 over sine theta, that's the AB part. Then I'm going to take the reciprocal of the second part, which is cosine theta, not 1 over that, but cosine theta over 1 is equal to, remember, can't change this, so I'm just going to bring it down, cotan theta. All right, bringing it down, I'm going to multiply here, straight across, obviously. I'm going to get cosine theta over sine theta is equal to cotan theta. This is true, but what I have to say is this. I have to say, what identity is this? And this is called the reciprocal, one of the reciprocal identity. So oh my God, I can't spell it. Reciprocal identity. All right? So that's for, let's just do one more and see if we can handle this one. So here we go again. We are tasked with proving that 1 plus cotan squared theta is the same or equivalent to cosecant squared theta. So this is how I'm going to work on this, I think. How am I going to do this one? I'm going to do the same thing here. Remember, left side, right side stays the same. So I'm going to change this to, what did this be? This would be cosine squared theta over sine squared theta plus 1 equal to this crap over here, right? It's going to leave this mess here. I'm going to start working on this. This is where this did get a tiny bit weird for me, is that I had to switch this out. I realized I had to add these together. So I'm going to replace my 1 with sine squared theta over sine squared theta. And if you're wondering why I did that, because this denominator over here is sine squared theta, so I needed to make it the same. And sine squared theta over sine squared theta is just that one, isn't it? So this plus sign is this one. I have cosine squared theta over sine squared theta equal to, remember, didn't touch this crap over here, left it just like that. So just brought that down. Now I'm just going to do what you would do when you add any two fractions together. Make sure that the denominators are the same. They are. We, of course, do not add denominators. So I'm going to leave it as sine squared theta at the bottom. And sine squared theta plus cosine squared theta. Sine squared theta plus cosine squared theta. And I'm saying that's equivalent to cosecant squared theta. Haven't proven it yet. Last step, I hope. From actually, this is the first Pythagorean identity, says that sine squared theta plus cosine squared theta is equal to 1. So I'm going to use the Pythagorean identity here, and I'm going to take this and say that this bit right here is 1. So I have 1 over sine squared theta is equal to cosecant squared theta. We actually have this proven because, again, we have another one of the reciprocal identities. So you call this recip ID, and your professor would be pleased. All right? Look, I hope this is really helpful. If you have any questions or comments, please let me know. Remember that you're only changing one side of the equation, and it's almost always a left-hand proof. So if you have any questions or comments, let me know. And if you haven't already subscribed, please do. Appreciate you guys. Peace.